Imagine like having to fight with a zombie with this thing on. And as I said, if you die from like a creeper, it's gonna it's gonna give you a good shock. So that's gonna be kind of funny. I mean, we need to buy a taser now, but all right, welcome back. So recently I've seen quite a lot of videos about creating a Minecraft tool that would tase you in real life if you take damage. So I thought, well, you know, I can also do that. So yeah, today let's try to create a Minecraft mod that will talk with an Arduino board over like a serial protocol, and we'll try to send the damage as input to the Arduino board, and then do some magic C code that will trigger something. I don't yet have something to tase me with, but we'll just use an LED to show when you take damage. And I mean, obviously we could connect it to live wires and tase us that way, but no, let's not. So let's start with uh, like an empty project. Let's call it, I guess for now, let's call it test Minecraft mod. And since I'm using NixOS, we need to create a new flake with some dependencies. And let's fill in our dependencies. Usually for my Nix flakes, I like to use, actually I think Markdown C is a good starting point. I like to use the same Nix flake, like the template, and I think it's pretty nice. It's using flake utils, and it's doing like a for loop over all the systems, I guess, and then it defines the packages that I want to use. I'm using unstable for some reason. I don't know why. I just added it at some point and kept it that way. Let's use for my Minecraft mod, and yeah, here it defines the default package. I don't think we'll have one, but anyway. And then for the dev shell, we need to fill in our build inputs. And for the build inputs, I guess if we check the fabric, because I'm going to use fabric, it's the easiest way to go with it from what I understand. I think it's an option is also Forge, but honestly I remember using Forge like 10 years ago when I was playing Minecraft, so I would assume it's kind of old. And from what I understand, fabric is newer, so maybe it's better, I don't know. Okay, I don't know where the documentation is though. So we have this example mod that we can use. Maybe we should actually just download this thing. Sure. I mean, we can just download this thing and just rename it to test Minecraft mod. Why not? So let me just actually, let's remove test Minecraft mod, and let's clone this thing. Can you actually git clone target? I'm pretty sure you could have something like target. Whatever. Oh, it's pretty nice. I see here template, whatever. So let's just git clone this thing, and I'm just gonna rename it. So just mvit fabric, and let's rename it to test Minecraft mod. And let's go back. So here I'm just gonna do nix flake init, and I'm just gonna fit this in again, so we don't need any native build inputs. Okay, and the reason why I would like to use the template I mean, it's basically giving you everything you need right away. You don't need to create any boilerplate. It's also creating all the dependencies, and obviously we are going to use Java, and I'm not that good with this Java. I haven't used it since, I guess I used it for Advent of Code, but yeah, I mean, it's kind of bad, honestly, so it's gonna be a fun experience. Okay, so I remember I was looking through the documentation for Fabric. I guess, was it here? Nope. I guess it has quite a few templates, but yeah, whatever. But from my experience with Fabric, it was really hard to wow, it's white. Sorry for the flashbang, but yeah. So developer guides. Okay, I think this is what I was looking at yesterday. The only problem I had with Fabric was, or I guess maybe it's just Java in general for me. I'm not used to programming in Java, but even though they showed pretty good examples, so I mean the examples are really good. You can just copy paste them and they are gonna work. And even how to set up the development environment is really good. It tells you which dependencies you need, and that's pretty nice for NixOS because we can just copy paste them. I don't remember exactly where they are, um, but I know. So creating a project, I guess here it's where, oh yeah, so this is how to clone the template. And obviously you can modify some things, and I guess you should modify some things about the template, like the mod ID, mod name, obviously. You want them to be different. But for our test example, since we are not gonna deploy this thing, maybe in the future we'll have like a refactored version that I'm gonna work a bit on to make it nicer and actually, get something to use as a taser, but that's, gonna take some time. Um, I might, change all of these things. But here it explains how everything works, and as I said, it has really nice examples which you can just copy paste. And the only problem I had with this was, even though it tells you how to use these things, it doesn't tell you where to import the classes from. And again, I'm not sure if this is just a Java thing or maybe it's just a Fabric documentation thing. You know, it was really hard for me to figure out where to import things from. So yeah, I mean, I have some kind of list that I'm gonna use to copy paste from. It's like a cheat sheet, but just for the imports. And I guess you could just go into the GitHub repo and search for the class, but come on, I mean, we can use grep, but yeah. So I think in the setup development environment, they show us, huh. So I mean, it tells us that we need GDK 21. So that's one thing that we have to add, GDK 21. Another thing that we'll need is Gradle, because that's the build tool. Oh, and something I forgot to mention. Oh, well, I guess with packages. And obviously these things, it doesn't depend that I'm using Nix. I guess if you're using Ubuntu or anything else, you can just install them with apt install, or even on Windows, it should be pretty easy to get GDK and Gradle. Something I forgot to mention is that the default branch is 1.21. So this is gonna work for Minecraft 1.21. So yeah, keep that in mind. And some other things that we are gonna need, I guess important ones are libgl. Oh yeah, I don't have libgl installed globally, so I have to install it for each project that requires it, which kind of sucks, but you know, you get the idea. Open all. I guess this one is for the audio, and alsalib as well for the audio. I guess these are just some libraries that you need if you want sound and graphics. And another one that I used to see some warnings about when I was running Minecraft, but I don't remember where I saw the fix. Or I guess I just added F-Light. This one I think it's for the narrator, but you know, it's not important. It's just something to add. And here for the project structure, not that interesting. I guess how the project is structured, we can, I guess, take a look. Is it has some GitHub workflows just for building. I'm not sure what Gradle wrapper is. Does it come with its own Gradle or something? I'm not sure. Or, yeah, I'm not sure what this is for. I would assume that to make the life really easy, it could come with some jar included, but I don't know. But as I said, it gives you like really easy, like a really easy script to use to start Minecraft with your mod loaded with Gradle W. And then in SRC you have client and main, and this is like the client and server. And for this one we are gonna look only in the client, and the main reason is it's mostly a client side mod if you think about it, because you want this thing to trigger a signal when you take damage on an USB port or an Arduino board. So it doesn't really make sense to run it on the server, right? Like, unless you have, I don't know, like a common server with a few people that are playing together, and you need complicated logic to figure out which person to shock. But if you run it on the client, it's just on your USB port, so that's kind of easier. And I guess the main entry point would be example mod client.java. So this file will have to modify and add our logic. Okay, so I guess these are gonna be the Java side requirements for running Minecraft. And maybe we can just build this because it's gonna take a while to download all of them. I guess I could have used, oh, actually it was pretty fast. Nice. Oh, and something else that we need to add. Usually I saw that you need this stuff when you have C libraries. We need to export LD library path, and we need to do packages lib make library path build inputs. Oh, and if we do that, we need to make this function recursive. Okay. And I'm not sure if we need this thing, but I used shell hook. I used this one in my Advent of Code flake. There were some languages that required language home variable to be set, and I assume Java was one of them. So packages.gdk 21. Okay, so pkgs. Right. And if we run the Gradle W, Gradle W run client, this should build everything and start a Minecraft instance. So let's run it. This is the part that's gonna take quite some time to compile. I don't remember how much it took when I was testing it, but it takes some time. So I guess until then I would maybe look over the C code probably until this one is done, Although, oh, I mean, it looks like it was done actually. Pretty
Press
fast.
enter to enable the narrator.
Jesus.
Narrator. 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 Off.
That was pretty funny though. Okay, so it's quite loud, honestly. Okay, so let me just... So now, we have the mod running inside of the game. And I guess if we check... Okay, so it says here, hello fabric world. So this is like a hello world message from the mod itself. So that's pretty nice. And yeah, I guess we could just try to add some things to our mod. So let's see. So I guess the first important thing would be to add the dependencies for the serial communication. And the one that I found was serial.com, jserial.com. So this one is what I found for connecting to a serial port from Java. And we need to add something like this to our dependency. So let me just copy paste one of them, and let's go to build.gradle, and we should have something like dependencies. And what I did was to do implementation, and then I added, let me just do something like com face cast. I think it was jserial.com, and then I did project.jserial.com underscore version, and then we need to also set the version, right? So let's copy paste this one. Let's go to Gradle properties. Let's add it here, and I think the version I used was 2.11.2, the one from the latest release, basically. So this would be the dependency for connecting to the serial port. Okay, and if we run this thing again, I think it should fetch that dependency. Let's just see. I mean, if it runs, you know what I mean? Okay, nice. Let's exit that. So we have, I would assume we have this dependency installed now. So we might be able to use it. And the fun part is that I don't have any LSP for Java, so that's gonna be pretty cool. So let's go to the main file, right? And obviously you would want to maybe rename from example to something else, but it doesn't really matter that much. Okay, and another thing that you will need to do to be able to use the like the serial communication is to add I think it's dial out. So let me see if dial out group. So yeah, to be able to use a serial device, you need to have your user in the dial out group. Otherwise, you need to use sudo. I'm not sure if it tells that. There's that here. I found, oh yeah, so I guess you also need the UUCP, but yeah, you need to add, basically just copy paste this command from the documentation. You need to add your user to dial out. I'm not sure if you need also log or TTY. I guess these ones are by default, probably. But yeah, so something that we can do maybe is to just test that serial port works, right? Well, see how in this documentation it tells you what to import, like everything from jserial.com. So maybe it's something like bad documentation on Fabric side, but yeah, I cannot tell that. But sure, we can create like a main.java file first and just test that everything works. So let's add that import. I guess we have to do public class main and then public static void main. And what's the system.out.println hello world. I think that's how you do hello world in Java. Okay, so let's compile main. Oh, if we want to use this package, you know, obviously you would want not to use javac directly, like you know, like a baboon, but you would want to use, you know, Gradle, like the build tool, because in the build tool we added the dependency. But right now the build tool, like build.gradle, is set up to run the Minecraft mod, so that's kind of annoying to change. So quick hack is to add the jar file. So we can just download jserial.com.jar and use -cp, which I don't know what it stands for, but whatever, and then the path to the jar file, and then the name of our Java thing. So we can just download. It's pretty small, so that's nice. So here we compile the main.java file. It should compile, nice. And then if we run it with cp again, and then we specify the paths to search for to be the current path, or I guess the current working directory, and the jar file with main, it should also, it wants the string args, whatever. Let's compile again and let's run. So it gives us hello world. That's nice. But something else that I would like to see is all the serial ports. So serial port array ports, we get all the ports, and I guess for serial port p in ports, I think that's how you write it, I'm not sure. Println, let's do p, and I think you can do something like get descriptor. Get descriptive port name maybe, so, or get system port name. Let's do get descriptive port name. If it prints a string, then it's good. So let's do this. Let's compile it. We need a semicolon. Let's compile it, and then if we run it, we should see like physical port. I don't know what physical port is, and then we see the serial device because yeah, I connected the Arduino board to my computer, so we can see it. Usually it would be listed in dev tty, and then I don't know, depending on your setup, it's either ACM0, or I think the other option is, let me just double check in my cheat sheet, I think it was USB 0, the other option. Not sure why it would be USB 0, but you know, it could be. Whatever, so it's basically this one, right? So yeah. Okay, and if we want to connect to the serial port, if we want to open one, I guess we can do something like this. Serial port, let's say, obviously you have to use this descriptor. Sadly, like, I'll show you at the end a way to make this process nicer and a lot cooler than just hard coding the value. Which, I mean, in my opinion, it's much nicer. So yeah, okay, so that's how we get the actual port, right? And to open it, we have to do something like, I guess it's open or open port. Yeah, it's open port. Oh, Java is one of those languages that allows you to redefine a function with different arguments. That's cool. So we can do something like if port.open port system.out.println open port. Okay, I'm not gonna type successfully, it's too long. And on the else case, it's like failed. Let's do like error. So if we run this thing, what? I forgot about that. If we run this thing, I would assume it's gonna say okay, right? So perfect. So it opens the port. It means that we can move further with all of this stuff because it's gonna work. So we are Gucci at this point. Okay, so let's remove the class in the Java file and let's go to the mod file. So example mod client. So what do we need to add here? Well, obviously, wait. Oh yeah. So obviously the import. First of all, let's import everything from the jserial.com. We'll also need print writer to be able to write to the serial port. So let's add that as well. So java io.print writer, and let's add some global variables basically. So it's gonna be private static serial port. So this is gonna be the port that we are gonna open. Then let's add private static print writer. So this is gonna be basically std out, if you will, but it's gonna be redirected into this port. So the same way that we use std out to print hello world, we'll use this writer to write to the Arduino board. So that's the main idea here. And this is like an interface, like in Rust when we did reading and writing to files, is basically a generic writer and will make it write to the port. So that's kind of the idea here. And let's add a couple of helper functions to close the port, open the port, do stuff like that. So first we'll start with close port, obviously. I mean, yeah. So if the writer is not null, then we can do writer.close and let's set the writer to null. And then if the port is not null and the port is open, then we are going to port.close and set the port to null, just to make sure that everything is fine. And the important function obviously is static boolean is open port. And the reason why I'm creating two separate functions is because we have these global variables, and I would like to use those variables in here in the onInitialize client, and we'll see what we're gonna do with them. So first, I'd say we want to do close port first, just in case it's open and we want to reset it. Then, oh, and another thing that this function will get as an argument, although let's just hard code it for now. I guess port is gonna be serial port dot get com port. So here we are just using this function that we did earlier, and obviously we know that this is the file descriptor that we need to use. So we get that port, then we can do something like port open port. If this thing works, then we can still do some println and say port was opened successfully. Why cannot I type sometimes? Okay, whatever. So that's gonna be this part, and then we need to create the writer. And I guess, yeah, I know you can create a writer at some other point, but just to make things simpler, let's create it here. So new print writer, and then port.get output stream, and this is basically giving us let me just copy paste. So get output stream, it's like returning a file descriptor in C, for instance, like an fd or like file, and it allows us to write to it. Okay, and I think the other argument, I'm not sure what it was, but it should be true. Okay, and now I understand why like Boolean arguments are kind of trash, because what does this one do? Not sure. Okay, and let's return true because we were able to open the port, and otherwise let's do like failed to open port, right? And I'm setting the port to null, maybe setting the writer to null, and return false, right? So this should allow us to open the port, close the port, pretty simple functionality. And obviously when we initialize the client, we want to open the port. And what we should see now when we run the Minecraft client is inside of the logs, we should see, I guess it's close port. Okay. That's why I like Rust more, because with traits you don't have all of these weird methods. You just have the trait methods, which is much nicer. So now we should see, if we search for successfully, port was opened successfully, right? So we get this this message here. Nice. So the next step would be actually writing the damage again as a function. So let's do static void send damage, and this one is going to take the damage as an integer, although the damage can be a float. But what I'm gonna do is, because let's think about it, if you take 0.1 damage, I don't know how you can take 0.1 damage in Minecraft. I guess from a creeper, if it explodes really far away. You still want to feel a shock, right? So it's gonna be a damage of 1. Or I mean, yeah, sure, fair enough. You know what I mean. So if the writer is not null, then it means that we can write some stuff. So let's do writer.write, and in here I'm gonna do damage and 0xff. So we are casting the damage to a char. So we are sending only a single byte in here in the write function. Okay, and I'm pretty sure we need to also flush just to make sure the thing gets sent. Otherwise, although I don't think it works like in C, where if you don't put a new line it doesn't print it, but maybe I'm wrong. Okay, and otherwise let's do like a system.error.println port is not opened, cannot send damage. Okay, so here we send the damage character as a character, so it's going to be a number from 0 to 255, and that should be fine because you cannot really take that much damage in Minecraft. It should be a number between 0 and 20, unless you have crazy amount of armor or you jump from a really high spot. So damn, I mean, imagine you'll see what if you take 1,000 damage, that's gonna be really painful, but you'll see why in a second. So yeah, we're basically just sending the damage as a character, so I would assume it's fine because usually the damage is gonna be 0 to 20, so yeah, I'd say it's gonna be fine. Okay, so this is how we send the damage. Well, I guess let's finish first the entire Java code, then we'll do the entire C code, and then I'll try to record the Arduino board, how it looks like. So I think that's gonna be the plan. So let's check out what we need to do in the initialize client. So we need, obviously just checking my notes, we need to add something called client tick events. So we need to look for this thing. I think it's from here. So see what I mean? It's like pretty hard to figure out which import to use. But let me just copy paste this thing and let's do something like import this dot client tick events. So we need this function, this class. Basically this class gives us access to things like end client tick, and how mods work for Minecraft. From what I understand, it's like injecting Java code in events like callbacks, and those callbacks can do certain things on the word. So I don't know, for example, here it has quite nice examples of creating an item, like modding a new item or modding a new block, entities, commands. Commands are nice, are really cool. I'll show you a small example at the end of using commands. Yeah, let's try to actually use this thing. So I'm gonna do client tick events, and we are interested in the end client tick. So basically on the end tick we can check if we took damage, and you know, with ticks you can think of this as a turn-based game, and on the end of the turn you can check if you took damage, basically. So that's the idea. So here we can register a new callback, and I think the callback uses a client as an input, so it uses only the client. So we can just add the client there. So this is going to be a new callback. Right, so here it creates whatever array with all the callbacks and it calls all of them. So that's the idea. when the tick, right? Yeah, I guess when the tick ends, it calls all of the callbacks that we register. So this would be one of them. Okay, so here, obviously, if we don't have a writer, we cannot do anything. But I mean, we already checked that, so it's not that useful. So let's create a. So let's get a player entity. To get a player entity, actually, do we have Minecraft GitHub code? Like we need, yeah, what they expect. So we need like the player entity, and the player entity is in the net.minecraft entity.player.player entity. Again, don't ask me how I found this one. Actually, I don't remember. Because it makes sense to be in the entities, but again, here it doesn't show you where to import stuff from, so you just need to yeah, I don't know, maybe I think I was looking through some examples or something, but yeah, anyway, so you get the player entity, and we also need Minecraft client, I think, for some stuff. Okay, so we have the player entity. Let's do player entity player is equal to Minecraft client dot get instance dot player. So this would give us the current player. I don't know how it will work with multiple players, but I would assume that the client keeps track only of the current player, and the other players are considered NPCs. So at least that's how I would implement a multiplayer game, right? So the local host would be the player, and the other players are just spawned in as NPCs, and their position is controlled by the network manager or something like that. Okay, so if player is null, we just return, cannot do anything. It's kind of impossible, but an unreachable case. So we get the current health, player.getHealth, and we need another global variable, funny enough, private float last health. Let's initialize it with -1, just so we know it has a default value. So if last health is not -1 and last, or I guess current health is smaller than last health, it means that we took damage, right? Or I guess here in this case, yeah, it means that we took damage, right? And on the else case, we do last health is equal to current health, right? So in this case, we actually took damage. So let's compute the damage that we took. So float damage is last health minus current health, right? And then we need to do send damage, and let's cast this to an integer, and maybe even just print it system out, print ln damage sent, and let's do plus damage. I like that it works just like JavaScript here. So it actually sends the damage that we take. Right, and here we open the port, and I mean, if it fails, it's gonna show us that it fails. So it's nothing really useful that we can do. So if we run the client now, I guess Java has that app thingy. Okay, if we run the client, if let's say we create a new world, and let's see if we can actually take damage really fast. Then, oh my god, I have bobbing. Was hoping, oh, actually, I guess we can just jump. Okay, so damage sent 5, right? So that would be what, like 2 hearts and a half, right? I guess it was, but it increased back. So I would say it's working, right? Obviously, we don't have anything running on the Arduino, so it's not gonna do anything. But the main idea is that we are able to write to the serial port now, which is kind of nice. So obviously the next step would be to implement the C part of the code and actually interpret that data. I guess, yeah, sure, why not? We can start on the C code. I don't think we miss anything from the mod itself. Again, it's just the serial port that we need to create when we initialize the game, and I'll show you a nicer way to actually not need to hard code the value, but it's more manual. And then we just need this end client tick. We need to add an event, a callback, and check if we took damage. And if we took damage, then we just send that value to the serial port. So now again we need to interpret that data. So first thing that we need to do is go into the flake, and we need to add a couple of extra packages. So yeah, I mean, I could use Arduino language to do the entire thing, but I like to use C for Arduino for some reason. I don't know, I just got used to that. So I'm gonna use packages cross.avr.build packages.gcc. So these ones I took from let me check, from my previous, oh, actually from the test Arduino project, which I was working on a while back, just to figure out what packages I need for an Arduino on Nix. So it's GCC and AVR dude. Let me just copy paste them. Okay, so we need this AVR GCC and AVR dude for copying the code. I don't know why it's called AVR dude. It's like, is it really dude, or it's like D for copy and D for paste or something? Yeah. Okay, so from here, we don't need bear, honestly. Let's actually nix develop to download the things until we figure out what else we need. I would also copy paste the makefile. So makefile, just one thing that I don't like. I don't know why it worked before. I noticed this one when I was testing. And the order of them is kind of weird. I would actually put them like this. So basically, here we compile the C code to an object file, then we compile it to an ELF, and this is not really the executable, although it might look like it. We'll check what file type this is. Then we use object copy to copy the text and data sections into a hex file. I guess this is like a byte string, or a byte stream, I should say. And then you use the AVR dude tool, whatever, to program. Since I'm using Arduino Uno, it's using Atmega 328P, so that's gonna be the microcontroller. Then the programmer is Arduino, port is the file, and here it's where I was checking, it's ACM0 or USB0, but usually it's gonna be ACM0, and on Windows I think it's COM3 or something. Baud, I think this was just copy pasted from somewhere and then flashing the main.txt file. So this does all of that. Nice. I think this should be all the setup for the C code. We can just... Oh, actually, another small thing that I would like to add is the compile flags. And the main reason for compile flags is just for Clang to work, because since I mean I don't have Java LSP, but we have C LSP, and you know, at least one LSP should be nice to have. Okay, so here this part obviously is not going to be the same, because you know, we need to do something like avr gcc print include, and we just need this part. It's kind of annoying. I don't know how to fix not needing to do this, but yeah, it's like whatever. It's basically we need to set the include path to the header files, right? Because we are gonna use like this is like the stdlib for avr gcc, right? Because it's not gonna use the same stdlib as Clang or GCC. It needs different functions because it has a different backend, if you will. It has like a different platform to compile on, right? It's not compiling for Linux, it's compiling for Atmega 328 for this microcontroller. Okay, or I guess the target is AVR, right? So it's a different target. Okay, so that should in fact give us LSP. I don't know, maybe I have to restart NVim one more time. So now we should be able to just not necessarily copy paste, but I'm just gonna copy paste some stuff. So yeah, sure, why not? So from here, let's just copy paste first the example just to make sure that everything works. I mean, you can see that we are able to actually see the defines for all of these things, which is kind of cool, and the like hover. Anyway, so if we do make upload, it should ask for my password and flash this thing. I would assume it works. I mean, I can see the blinking light every second, so yeah, we should be good to do some stuff. So we are gonna use AVR IO. Why I use that? Yeah, why not? So let's include some other things that we are gonna use: AVR IO and AVR interrupt. Yeah, we are gonna use interrupts. That's gonna suck, but it's better than using delay, because delay is basically a blocking function, and if you call delay, you cannot really read from the serial port at the same time. So if you call delay, the Arduino board is blocked, it cannot do anything. And if we use interrupts, those are gonna be called only when needed, so it's not gonna block the Arduino board, so we are gonna be able to receive messages that you took damage to increase the pain that you need to feel, right? So yeah, so here it's, again, I think it's like blocking. I don't know how it works specifically, but while loop is blocking. Okay, so we are not gonna use that. Okay, so let's define a couple of things, like baud rate is gonna be 9600. This is the default value from what I understand. Then define my Uber charge. Honestly, no idea what this is used for, but you know, ChatGPT recommended this stuff, so bound -1. Yeah, I mean, you know, honestly, just copied some of these things from ChatGPT, and to be fair, it actually gave really good answers. No idea how it got this good at writing C code for Arduino. Like, I remember last year it was complete garbage, but now it actually was kind of decent at using the right flags and ports. So first things first, we need to initialize our serial port. So we are gonna use unsigned int. Uber is my Uber charge from Team Fortress 2. Then, jeez, I need to zoom in a bit. Sorry about that. So we need Uber 0h. So the high part is gonna be this. Again, honestly, not really sure what all of this does. Just blindly trusting ChatGPT. Right, but at least for the next part, it's kind of familiar. So UCS R0B. This one is setting the receive only. So we are just gonna read from the serial port. So we need to do receive enable 0. And I guess the next one is for something like encoding probably. So wait, there's a good one in here when we do open port. I think it was somewhere here. Some function in the Java code that was a bit nicer to look at, but yeah, like data bits and stop bits and parity bits. This is what we are setting now basically with in this register. But yeah, so yeah, you know, we could just copy paste it, why not? So I had here like a step-by-step guide on how to implement this thing. So basically this part, we can just copy paste it. We could look a bit over it, but it's like, okay, so we don't need this one. We need this one. Okay, so yeah, basically this sets this parity bit and the stop bit. Honestly, not sure what they represent, but I would assume it's like the end of file for sending messages, and the parity bit, since we looked over Hamming encoding recently, I would assume it has to do with encoding, like error correction. So yeah, and then for word read, this one is basically while here it waits for a new message and then it returns the byte that it read, right? So it gives us a byte, and since in the example client, when we take damage we send 1 byte, this thing is gonna read the damage that we take. So that's the idea here, right? Next, let's do the entry point first, and then we'll do the actual timer, right? So here we want to set port 13 for the heartbeat check. So it's basically a default LED on the Arduino board to see if it works. And then I'm gonna use port 12, so PB4, for sending the damage output. Okay, so then we need to do wart init to initialize the serial port. Then while true, let's remove everything from here. We can do something similar to here. So if we have anything on the serial port, we are gonna wart read and uint 8t data is equal to that. And if data is 0, so if you took 0 damage, we are still gonna set it to 1, just in case. And there's not really a good way to debug unless we do here something like 1 tx en0, like also enabling sending back, but maybe we need extra setup, so I don't know. Let's just not let's just ignore that part for now. All right, so this would be the main logic for opening a serial port and then reading from it. All right, and the next part that we need to do is to set up the timer. And honestly, you know, I remember from the, maybe it's just the, how do you call it, the PTSD from the uni, but Jesus. So let's start with a simple timer first. So we'll need the timer works like this. It sets up like a clock, and it runs in ticks, like just like Minecraft basically. So on each frame, you can think is gonna do something. So in each frame we are gonna have this blink counter, and we are gonna increment it. And once the blink counter reaches the blink delay, or 500, it's gonna reset back to 0, and it's gonna do something. And that's something, for instance, it can be flipping the pin for this LED and setting it from high to low, and it's gonna do that every 500 milliseconds. So if we set up the clock to run with a frequency of like what, 1000 hertz, or like every millisecond, this would represent like 500 milliseconds, right? So that's the idea. So we want to do something like that. So let's go ahead and obviously just copy paste this timer init method. So again, this just black magic, setting some things, enabling the interrupts, but basically this will run it at I think 100 hertz, if I'm not mistaken. So each blink will represent 1 millisecond, right? And this in total will be 500 milliseconds. I think that's what this does. But you know, don't quote me on that. Obviously we need to do timer 1 init. Obviously, you know, if you want to be precise, you would open the spec for @mega. Actually, let's do that. @mega gateway p timer documentation. So timer 1, Jesus, timer 1. Yeah, I mean, okay, this one, timer 1. Jesus Christ. I mean, I know there are some tables with how to set up but honestly I don't remember where they were. Okay, so here it's something. Maybe let's search for something like this. Yeah, I mean it explains here how to use. So the important part usually is in the register description. So how to use this thing basically. Um, Timer control register A. We don't even use that. We use TCCR1B. And if you remember from, um, I think in the last time we did Arduino, like 1 year ago, we looked into these things quite a lot. But for this one I was kind of lazy to do it, so yeah. Okay, so this one was the one that I used, control register B. So if we set WGM12, so it's bit 3. See the waveform generation mode. See the description for TCCR1A. Interesting. I would assume it's kind of similar to that. These bits control the counting sequence of the counter. The source for maximum top value. Huh. Okay, so I guess if we set WGM12 to 1 and all the other ones to 0, it's this one. It's this line, mode 4, and it runs in CTC mode. It takes the top value from OCR1A, so OCR1A is 16,000. Update of OCR1X at immediate. I don't know what that means. And flag set on max. So I guess max does something. But what's kind of important for us is the timer to reset itself and start from the beginning. So yeah, again, I don't know what exactly, I guess if you know what you want, you can try to search for how to do that, but yeah. So team TI mask 1, what does this one do? So this should be like in another section, TI, right? TI mask 1, interrupt mask register. So we are setting OCI E1A, so bit 1. Output compare A, match interrupt enable. When this bit is set to 1, I'm not sure. And then for TCC R1B, I think I skipped it. 1C and 1B. Control register B. Oh, so it's, wait, what the fuck? It's the same as this one. Okay, fine, fair enough. CS10. So bit 0, the 3 clock select bits. So it's like 001, no prescaling. Again, not really sure what all of this means, but hopefully it does what we expect. So hopefully it does basically just counting, and then when it reaches the top value, it goes back to 0. So yeah, something like that. Okay, anyway, so that would be how we initialize the timer. We call it, so this would start a timer, or I guess like a clock signal, And the other important thing would be to set up an interrupt ISR, interrupt service routine. Let's copy paste it. And this one would increment the blink counter, and if the blink counter gets over the delay, it flips the port 13, which should flip the LED, like the heartbeat LED. So that's the main idea here. So let me just do make upload. Okay, so the LED is faster, you can trust me. It blinks in and out every second, so it's 500 milliseconds, so that's good. Okay, and the last thing that we are gonna do, I mean, you know, hopefully by the same logic it makes sense. I guess I can explain what we want to do when we take damage. So yeah, let's copy paste these values, right? So basically the damage delay is how fast each shock is gonna be, so 100 milliseconds for each shock. Then damage counter is you know, counting up to 100, just like blink counter. Then damage active, you know, you don't want to take damage if you don't take damage in game, so we need a flag for that. And then the damage step is basically how many hit points of damage you took in game. So here, for instance, what we can do in the main function is to increment, I guess, the damage steps with the data. So I will do something like damage steps plus equals data, and we don't want to reset the damage steps to just data because we want you to keep taking damage for the old damage, right? So if you took 5 hit points of damage and then immediately took other 5, it would be like 5 plus 5, so it would buffer the damage. You know, it's really annoying, but and we set the damage active to 1, so we reset the flag to 1. And here obviously if damage flag, damage active, then we want to kind of do the same logic as we did here. So we are gonna do damage counter plus plus. Then if the damage counter is greater or equal than damage delay, it means that you took some damage. So we are gonna do port B, let's flip it PB4. So we're gonna use a different pin for the damage dealing part. Then damage counter gets reset to 0, just like blink. And then we need to do damage steps minus minus, right? So we subtract 1 from the damage buffer. Then if the damage steps is less or equal to 0, we want damage active to be 0. I would also say damage steps is equal to 0 just in case. And let's make sure that port B is let's actually make sure that the port B is actually set to 0, because otherwise whoops, you would get fried. But yeah, I guess that would be everything for the C code. Right, so while you can take damage, we just do the same thing as we did for the blink, but more times, right? Or I guess deterministic amount of times. Here we do it like while true, and here we do it only if damage is active. Right? Basically, that's the idea. Okay, so let me just make upload. just to make sure that everything works. And first, let me just, let's check if it's gonna be a first try situation. So, I was hoping to find a world with lava, but sadly we didn't. Let's explore a bit. Wait, do I have head bobbing? Oh my god, that's so annoying. I don't know why head bobbing is on by default. We really don't have lava. Okay, let's I think I saw something on the Arduino board. Let me just try to find a word that has some lava in it. So I'm just gonna pause the recording. I mean, you won't believe it, but it was actually the second word that I generated that had a portal right next to the... Okay, so if I... So it says damage sand, but I don't see it appearing on the Arduino board. So we set up everything, even the timer. Damage active. We flip this one. I'm just trying to make upload again. Or maybe something is disconnected from the... I think it was this one. I mean, the Arduino boards receive LED lights up. So, at least we know that it receives some data. But yeah, not sure why the LED doesn't light up. Maybe it's something that's disconnected. Let me just double check that it works fine. Okay, so I figured out what happened. So here we need to multiply the damage by 2 because here for every step that we go over the damage delay, we flip the port. So instead of just doing another while loop in here and doing complicated if statements, if we double the amount of steps that we need to take, first it will flip it to high, then the second time it will flip it to low. And otherwise what was happening here was that it was flipping it to high, then the damage steps was going to 0 and flipping it immediately to 0. Right, so this was the main issue here. And the reason why I saw that the LED lit up for a brief second was that when I did a jump and took like 5 damage, it actually did 2 steps, so then it worked. But when I was stepping on the lava thingy, I don't know what it's called, I haven't played Minecraft since they added those things. But yeah, here, now it lights it up. So now let me just maybe show it like a quick demo of how it works. I think that would be kind of funny to see. Yeah, I don't know if I want to show how I did the setup, but I mean it's pretty simple. I just connected ground to the ground line there, like the minus, then port 12 on the Arduino board to +5. I mean, it's just quick dirty work. Then I added like a resistor. I think the resistor is fine for the LED. Hopefully someone will see the... Let me just close up on it and show you the values. I think it's a 200k ohm resistor. I haven't checked it honestly, so kind of lucky that it didn't fry up the LED, but I have some. And then, you know, just put the LED, I think it's plus, yeah, plus for the plus, and the minus leg for the resistor. So yeah, and if I now go over the lava, it basically lights it up for each HP that you take as damage. So obviously it would be kind of funny to have some kind of taser connected to the LED and then to you. And then you can imagine that if you take 10 points of damage in a hit, it would light up like 5 times. Or I guess 10 times, right? So it would shock you 10 times, which would be even funnier. I think it would hurt more if it goes up and down, because it gives you a short break rather than just have it continuously uh, going, right? So yeah, this would be kind of fun, and maybe, I don't know, maybe a punishment if you actually die, but yeah, that would be the idea here. So yeah, hopefully this was an interesting project. Again, actually, you know, I actually said that I will show you a cool way, like refactored part of this project, because I was working on something. So let me just start up the shell in this one as well. So in this other project, I actually renamed some of the files. For instance, instead of example, I renamed it to damage.io, and a bunch more imports. I know. I added some commands. I was playing around with it, and I added this serial command, and then it has a subcommand of open, and then you specify the port. And for the port, I added this suggestion provider, which is kind of fine, like really cool thing to use, I think, because it lists all the ports that you have available, and you can choose one of them. So that's really nice. And you know, it opens the port. Then I added like a send command for testing purposes, and then close is just for closing the port if you're getting bored with it, right? And then I have the same function that we did together here, checking the player health and sending the damage that you take. Now I added a class for the damage message, mainly because we have two things that we send, right? So we have here, we are sending a value for testing, and I use the blink message here, and here I used a damage message. Difference between them is, oh, I guess I don't have an LSP, is that for the damage message we send a byte D first, and then we send our data, and for the blink message we send a B byte and then the data. So it's like a message header, if you will, right? So here we send the header and then the value. So that's the idea. You can have more complicated logic, like come up with your own protocol for sending information through the serial port. But the rest of the code is the same. So we just open the port, we close the port, and yeah. But I thought that this was a cool little feature here for doing that. So let me make upload just to have the old code here. And for the C code, it looks exactly the same, but it has this message struct. And basically the message struct, it can have a type, either B or D, or I guess unknown, and then the blink value and the damage value. And it works exactly the same. There's nothing different. Or I guess I created this UART read message that reads 2 bytes. So first it reads a B or a D, and then it reads the value. Otherwise it says the type to unknown. And the rest of the stuff is the same, I think. Nothing really changed. Yeah, so here we are reading if we can read a message. The blink value, I guess for the blink what I did was use it as the damage delay, so you can you know, change it if you want to have higher spikes, or I guess longer spikes. And here is the damage active. Oh, I guess here I should have also done like damage steps is equal to 0 just in case, right? Just so it's the same code. But oops, make upload. But yeah, so here if we run the client, again, as I said, you have to do a bit of manual stuff with this one. Oh, so this one has the loud music. So here, this one I think, okay. Oh, this one had lava right here. Oh shit, let me just go in the, oh my god. Let me just go in the water. Why does it come after me, bruh? Okay, so the command would be like serial open, and then you can see the actual port appearing as a suggestion, so that's kind of cool. So now that's why I said it's manual, because it requires you to open the serial port for the Arduino board to actually get messages when you take damage. But I mean, maybe that's a better way to do it, because you can actually stop it if you want. Oh shit. So here if we jump in the lava, it actually blinks like crazy. But yeah, so the fun part would be actually maybe serial send, let's say 200. So this would make it like have longer pulses. I wanted to try to record, to try and record the, so if you take, like, it has longer, I don't think it's actually visible that well, but let's maybe send a shorter one. I mean, for 2 it's not, I mean, you can see it actually, but it's way too fast. Okay, so again, I guess 100 was a good value for this. Imagine like having to fight with a zombie with this thing on. And as I said, if you die from like a creeper, it's gonna it's gonna give you a good shock. So that's gonna be kind of funny. I mean, you know, we need to buy a taser now, but and I mean, it's gonna, you know, turn Minecraft into something like a horror game. So that's something pretty cool. So yeah, basically this was the entire idea of how to create this kind of Minecraft mod. Obviously it's missing, you know, the most important part, which is the dazing, but you know, so I guess how we can connect that, right? So depends on what kind of taser you buy, but it's probably gonna be controlled by maybe a transistor, I guess. Depends how big that thing is. Maybe it's something that has a switch, like, I don't know, like those kinds of prank pads, you know, that you the commercials that sell abs, like the, you know, stuff to build your abs, like those things I think could work, or some kind of strap But yeah, I mean that would be, I guess, all for today, like the code part. I probably will come with an update if I ever buy one of those things, or if you want to actually see it working like that. Maybe like a really short video, like an actual short or something of that thing actually working, because it would be just replacing the LED with the switch for that thing. Um, Obviously, if we had a relay, we could connect it to live wires, but don't do that. I mean, I'm a trained professional. Don't touch live wires. I mean, that's don't sue me if you touched live wires because of this video, but that's an option. I mean, it would be actually, if you die in Minecraft, you die in real life, but we don't want that. So yeah, hopefully it was a fun video. Like, it covered quite a lot of topics, I would say. Um, and yeah, I mean, the only sad part is that you need to learn Java to mod Minecraft, and the other part that kind of sucks is you need to know a lot about Minecraft Java and Fabric Java. Like, you need to learn a lot about these libraries to be able to do anything cool. Because the documentation, it's not really there, so, or at least it's not that great as you know as I'm used to, like Rust documentation, even C documentation. I mean, that's non-existent, but it's really easy to look through the code in C. So yeah, or I guess Python documentation is really good as well, right? But I don't know, for Java, I was having higher expectations, especially because Java has a lot of Java docs, and it's really like focused on you adding comments and stuff. But maybe I'm just bad at searching for documentation because I don't use it that much. So yeah, I guess that's my take on Java. And the LSP, I wasn't really sure um, how to make it work with external libraries, like third-party things. That's also something I need to figure out if I want to do more Java, but honestly, I don't want to do more Java. I think games that allow you to code in Lua are nicer for modding. Although I think, now that I think about it, most games won't let you use like a serial port from Lua. They have like a gardened Lua, if you know what I mean. It's like you can only use certain functions and certain functionalities, but with Minecraft you can actually do whatever you want. Like, you can even I don't know, create a mod that would allow you to SSH into your own computer and like use your own computer from Minecraft or something like that. That would also be a fun challenge to try, but whatever. So yeah, I mean, it's extremely powerful for modding, but not a big fan of Java. So yeah, that's my take. So yeah, hopefully it was interesting. I'll make this repo public. It was private, or I guess I haven't created a repo for it, but yeah. So this would be everything for today. Hopefully it was interesting, and we'll see in the next one. So until then, see you.